Hi, ladies and gentlemen, we are on notes 12.1, which are on vertical and horizontal shifts. We're going to be discussing multiple different types of transformations to functions in this unit, and we did a lot of stuff using our graphing calculators to discover these different transformations. So hopefully what we're about to discuss isn't going to be anything totally new to you. So in the boxes on top, it says summarize what we have learned in the transformations of graphs activity. So hopefully you guys understood by doing the activity that if you take f of x and you add a k value onto it, it's going to shift your graph up. And if you take f of x and you subtract a k value from it, it's going to shift your graph down. Now, one thing I want you guys to understand is remember f of x is the same thing as y. So what we're doing is we're really technically right here taking a y value and adding k to it. And that would make sense that it would be a vertical shift, okay? And then remember when you had horizontal shifts left and right, you ended up with f of x minus h. That will shift it right. And the reason why it's shifting it right is because we figured out that it was going to be the opposite. Now notice also that the h is combined with the x. It's inside of your parentheses. So it's still part of your input, which would make sense that it's your horizontal shift, because if it was on the outside of your parentheses, then we would be subtracting h from the y value. Here we're subtracting h from the x value, so it makes sense that it is a horizontal shift. And then if you're shifting left, it would be f of x plus h. Now remember, it's the opposite. It's not going to go, if it's to the right, you would assume that it would be f of x plus h. But don't forget that it's like setting x minus h equal to 0. So the h value would technically be a positive h right here. Okay? So now let's take a look and see what's being written right here. Graph the following functions using their parent functions and your knowledge of vertical and horizontal shifts. So the first thing that we need to do in question number 1 is identify what is my parent function. So my parent function right here is the quadratic function of x squared. So here, this is my parent function. And then I have to identify, well, how do I graph out my parent function? Well, if I have x and f of x, I know if I'm going to go from negative 2 to positive 2, I know negative 2 squared is 4, that negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And at this point in time, we should get to a point where we're able to do this pretty quickly. Our parent functions are easy functions for us. So then if I were to graph it out right here, these are where my coordinates would be. However, this is not g of x. This is still f of x because I'm still graphing out my parent function, okay? So right here, I've got my parent function. So this is f of x, all right? And what I want to do is I want to figure out how is my parent function going to transform to get my actual function. Well, in order to do that, I have to look and see what's happening right here. I'm adding 2 to what would be equal to f of x. So right here, f of x equals x squared. So this right here is f of x. And then I'm adding a k value onto it, right? So that means that it's a vertical shift. So for this one right here, what's happening is I am taking x squared plus 2 and I'm vertically shifting it. So what I'm going to do is I'm going to write down right here that it is a vertical shift up, which is a little redundant, I know, because vertical and up go together, of 2 units. So I'm literally going to take each one of my each one of my points right here, and I'm just going to shift it up 2 units. So right here, my first point is at 4. I'm going to go up 2. Here's my new coordinate, okay? My next point is at 1. I'm going to go up 2. Here's my new coordinate. The next one is at 0. I'm going to go up 2. There's my new coordinate. The next one is at 1. Go up 2. There's my new coordinate. The last one is at 4. Go up 2. There's my final coordinate. Connect your dots right here. And then this right here is really g of x equals x squared plus 2. And that's the one I care about. So what I'm going to do is I'm going to erase or delete, in my case, my f of x graph. And now I know what my g of x graph looks like. Okay? Look at question number 2. In question number 2, it tells us that h of x is equal to the quantity x plus 2 squared. So same thing, I need to figure out what my parent function is going to be. And my parent function is again going to be f of x is equal to x squared. So I already figured out my table of values over here to figure out what the parent function will look like. So I'm going to graph out my parent function again because it's going to be my basis for doing my transformation. Okay? So right here, this is what my parent function will look like right here. So this is f of x. And what I'm going to do is I need to figure out what type of a transformation this is right here. Well, if you notice right here, this x plus 2, the plus 2 is inside of my parentheses, so it's part of my input. So that means it's a horizontal shift. So I'm going to shift it, and since it's a positive 2 right here, remember we go the opposite way, so that means that we have a shift to the left 2 units. So I'm going to take each one of my points and I'm going to graph it out 2 units to the left of the original point. So right here, my first point right here is at -2. My x value is at -2. I'm going to go to the left 2, and there's my new point. I do not have to go up or down because this is only a shift to the left 2. Same thing with this one. I'm going to go to the left twice, go to the left twice, go to the left twice, and then my last one I'm also going to go to the left twice. So this right here is my function h of x equals x plus 2 quantity squared. Okay, and then I'm just going to erase my previous graph so that way I have the actual graph that it asked me to graph out. Okay? All right, so now we're going to look at question number 3, and number 3 says the k of x is equal to the absolute value of x, and then I'm going to subtract 3 from that. So I need to figure out what my parent function is going to be. My parent function is going to be f of x equals the absolute value of x. So I'm going to create a graph, I'm going to create a chart so I know where to graph out these values. So I'm going to go from -2 all the way out to +2. And the absolute value of -2 is +2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So then all I have to do is just graph it out. And remember, we discussed earlier that if you have an absolute value graph, we figured out it's always going to look like a V, okay, some type of V. I'm going to extend my graph right here, just like we would extend our linear functions. So I'm going to keep going with my graph so I can kind of see it a little bit better. So here is my parent function. So now I have to figure out, well, what is my original problem asking me to do? It's asking me to take my parent function, and since this -3 is on the outside, it's part of my output, so it's going to be a vertical shift. So, and it's -3, so this means that it's going to shift down 3 units. Okay? So if I were to take each one of my points and shift it down 3 units, for example, this point right here, which is called the cusp, I would go down 1, 2, 3 units right here. Take the next point, go down 3 units right here. Keep going with it. The next point, go down 3 units right here. I'm going to go to the other side. Take this point, go down 3 units. Take this point, go down 3 units. And then this right here is what your new graph is going to look like. So this is k of x is equal to the absolute value of x, and then I'm going to subtract 3 from there. Let's erase our parent function, and now we know exactly what our graph is going to look like. Okay. All right, so let's take a look at question number 4. It says a of x is equal to the absolute value of all of x minus 3. So again, same thing, I need to figure out my parent function. And since it's absolute value, our parent function is the absolute value of x. And so I have my table of values right here, but I also just know that the right half of my absolute value function is just y equals x, and that the left half of my absolute value function is just y equals negative x. Okay, so if I were to connect it right here, this is what my graph looks like, but I need to figure out what kind of a transformation I have going on here. So in order to figure that out, I have to look at this right here and ask myself, which way is this graph going to go? Well, the -3 is part of the absolute value. It's part of the x value. It's part of the input, which means it's going to be a horizontal shift. And remember, we go the opposite direction of what the sign says if it's a horizontal shift. So if it's -3, it means it's going to shift it to the right 3 units. Okay, so let's go ahead and take each one of our values and shift it to the right 3 units. So 1, 2, 3, that's where my new cusp is going to be. 1, 2, 3. Take this point, shift it to the right 3 units. Okay, and then I'm going to take this point, the left side of my graph, shift it to the right 3 units. So 1, 2, 3. And then I'm going to take this point, shift it to the right 3 units. 1, 2, 3. And so this is what my new absolute value graph is going to look like. So this tells me that a of x is equal to the absolute value of x minus 3. All of the x minus 3 is within my absolute value for this one. So erase your original graph right here, and this is what your graph is going to look like. Right. One thing I want to point out to you about questions 1 through 4 is the similarity in the way that the equations look. So if you look right here, our first equation right here says g of x equals x squared plus 2, and h of x equals the quantity x plus 2 squared. But they do two completely different things. And the first graph will shift it up 2 units, but the second graph will shift it left 2 units. And I put them specifically with the same numbers so you can see the relationship between the two graphs and how they're not exactly the same thing. Okay, and then same thing with number 3 and 4. This has a -3 and this has a -3, but they do completely different things because this -3 is on the outside of the absolute value and this -3 is on the inside. So when it's on the outside, it affects your y value. When it's on the inside, it affects your x value. So if it's on the outside, it goes down 3, and if it's on the inside, it goes to the right 3. All right, so let's take a look at number 5. In number 5, it says r of x is equal to 2 to the x plus 3 power minus 4. So now things are going to get a little bit more complicated. The first thing I need to do, again, is find out what my parent function is. And my parent function is going to be f of x equals 2 to the x power. It's going to be an exponential function. So again, I'm going to make a list of values so I know exactly where to graph out my function. So I'm going to put x here and f of x there. And I'm going to start it at -2. That's a -2, -1, and I'm going to go all the way down to +2. Now, don't forget to figure out what f of -2 is. It means you're going to do 2 to the -2nd power. Well, 2 to the -2nd power means 1/2 squared, so you should get 1/4, okay? And then if I were to do this for f of -1, f of -1 would be 2 to the -1st power, which ends up being 1/2. So this value right here is 1/2. If I want to figure out what f of 0 is, then I'm going to plug in 0. So this is going to say f of 0 equals 2 to the 0th power, which is equal to 1. So this right here is 1. F of 1 would be 2 to the 1st power, which is 2, and f of 2 is 2 to the 2nd power, which is 4. Okay? I sped up a little bit at the end, so if you have any questions about that, write yourselves a note and I'll help you out with it in class. So let's go ahead and graph out our original function, our parent function. So I'm going to go to -2 1/4 right here. I'm going to go to -1 1/2. I'm going to go to 0 1. I'm going to go to 1 2, and then I'm going to go to 2 4. And it appears to have that exponential growth look to it. So this is what the parent function will look like. Notice how it will never touch the x-axis right here. Now, I need to figure out what's happening to my graph. Well, right here, this x plus 3 right here is telling me that it's going to the right, or excuse me, it's going to the left 3 because it's part of my input, okay? And then this minus 4 right here is telling me that it's going down 4, okay? So I'm going to take each one of my coordinates, and I have 2 shifts this time, left 3 and down 4. So I'm going to take this value right here, which is at a quarter. I'm going to go to the left 3, 1, 2, 3, and then I'm going to go down 4, 1, 2, 3, 4. So I end up at negative 3 and 3/4, okay? So I'm slightly a little bit above negative 4, okay? And then the next point right here, which is at a half, I'm going to go to the right 3, 1, 2, 3, and then I'm going to go down 4 again, 1, 2, 3, 4. So now I'm at a half, okay? I'm going to just erase this and bring it down a tiny bit because it's not quite low enough for me yet. This one right here, this point, I'm going to take it to the left 3, 1, 2, 3, and down 4, 1, 2, 3, 4. And then this coordinate, same thing, left 3, 1, 2, 3, down 4, 1, 2, 3, 4. And then my last coordinate, I'm going to go to the left 3, 1, 2, 3, down 4, 1, 2, 3, 4. And so now this is what my new graph will look like. So now really quickly, notice how this levels off at 0 right here. So this should level off right here at negative 4. So if I were to extend my graph, it would end up looking just like this. Okay, so this right here is r of x is equal to 2 to the x plus 3 power, all minus 4. Erase the original right here, or the parent function, excuse me, and then we are good to go for this graph, okay? And then our last one right here is t of x equals the quantity, or equals the square root of x minus 1 minus 2. So let's figure out our parent function. And our parent function is going to be the square root of x, because this right here has square root right here. So what I need to do is I need to figure out what my original values are going to be for my parent function. And remember, when you take the square root of any number, you can't take the square root of any negative number at this point in time. So the first number that we're going to try to take the square root of is 0. And the square root of 0 is 0. Next number I can take the square root of is 1, because the square root of 1 is 1. All right, and then the next number I can take the square root of is not 2 or 3, because those are going to give us irrational numbers. I can do it if I want to, but I don't want to deal with decimals at this point in time. So the next perfect square is 4, and the square root of 4 is 2. So when I graph this out, my coordinates are going to be 0, 0, 1, 1, and 4, 2. Okay, and so this is my parent function right here. Okay, and remember, it's going to be curved because it's the inverse of the square function. So make sure it doesn't look like a line. It's going to be curved. And the next value that we would have here would be at 9. So if I were to look at it, 9 would correspond with 3, so it's going to be all the way out here like that. Okay, because the square root of 9 is 3. So now I need to figure out, what is my graph saying I'm going to do? This is saying that I'm going to go to the right 1, and this is saying I'm going to go down 2. So if I go to the right 1, this coordinate right here, I'm going to go to the right 1 and down 2. This is where my new point is going to be. Same thing here. If I go to the right 1 and down 2, this is where my new coordinate is going to be. And lastly, right here, if I go to the right 1 and down 2, there's where my new coordinate is going to be for that one. And this is my actual function right here. So this means that t of x is equal to the square root of x minus 1, and then minus 2 is on the outside. Okay, erase your parent function right here, and then we should be good to go for that question. All right, guys, hang in there. We are almost there. So question number 7 says, given the parent function f of x equals x cubed, find the equation of the function that is the transformation of f of x when shifted up 7 and to the right 8. So for our original function is f of x equals x cubed. How do I figure out what our new function is going to be? Well, what I'm going to do is I'm going to take x cubed, okay, something is going to get cubed, but since it's going to the right 8, it means I'm going to subtract 8 from my x value, because again, when it's right and left, it's the opposite sign. And then it's also going up 7, so on the outside, because this is now part of my output, it's the vertical distance, I'm going to add 7, and that's what g of x is equal to. Okay, now let's take a look at number 8. Number 8 says, given the function f of x equals 3 times the quantity x minus 5 squared plus 4, find the equation of the function that is the transformation of f of x when shifted left 6 and down 2. So let's figure this out. First of all, one thing that you guys need to understand is just by looking at this, I can tell what my vertex is. And my vertex is going to be 5, 4. And if it's shifted left 6, that means that this 5 will become a -1. And if it's shifted down 2, it means this 4 will become a 2. But let's just double check and do the work properly so we can make sure that we have the right equation. The 3 has no effect at all on whether it's shifted left or right or up or down. So the 3 stays the same. Then I'm going to copy down the x minus 5, and if it says that it's shifted left 6, that means that I need to add 6 to my x values, okay? And then I'm going to square that because that's what the original function says. Then I'm going to copy the plus 4 down, and if it's shifted down 2, that means that I'm going to subtract 2 on the outside. So then when I combine my like terms right here, I end up getting g of x is equal to 3 times the quantity x minus 1 squared plus 2. Excuse me, 3 times the quantity x plus 1 squared plus 2. And that will give us our vertex of -1, 2. Okay? All right, last one, number 9. The function shown below is f of x. Draw in g of x if f of x equals, if g of x, equals f of x plus 2 minus 1. So it's f of the quantity x plus 2 minus 1. So the first thing I want you guys to do is identify what type of a transformation this is. So there are 2 different shifts that are happening. Please figure out those 2 shifts and then come back to me to see if you're right. Okay, so you should have gotten that this went to the left 2 and that this is going down 1. All right, so let's go ahead and do that. Let's take each one of my points and go to the left 2 and down 1, and then we'll be done with this problem. So right here, this first point starts right here. If I go to the left 2 and down 1, there's my new point. Okay, if this point starts here, I go to the left 2 and down 1, it's right there. If this starts right here, go to the left 2 down 1, it's right there. Okay, here, if I go to the left 2 and down 1, it's at -2, 0. Now watch out, this one's at 1/2. So if I go to the left 2, I'm going to go to -1/2 and then -1.5 and then down 1. So it'll end up being right here, in this spot right here. Okay, so again, it will end up being right there. If my computer will let me graph it out. There we go. And then this one right here, go to the left 2 and down 1, it's right here. And then this one, this point right here, this 4, 0, go to the left 2 and down 1, and it's right there. All you have to do now is just connect your dots and make sure it has the same general look as the original function, because you're not changing anything, you're just moving it into a different spot. And this right here, your blue function, is now your g of x. Okay? And our red function right here is f of x. If you have any questions, let me know. I'll see you next time in class. Have a great day.